Hi, folks. Let me know if you can hear me okay. I think I've got things pretty well set up. Let's maybe switch to something better than me to look at. Maybe this. Cool. Sounds like okay, I got it all figured out mostly. Can see people chiming in. So I'll say hello to a couple of folks here, I guess. Hey, Dawson, one of my former students is on here. Awesome. Even in the summer, still learning something. That's great. Thinking One Respect out of Canada. Welcome, Sharon. Thank you, Greg. Talked a little bit with Greg. And from Santa Barbara. Let's see, David, Troy, Dan, and Jack. Hey, Jack. Jack took me on a nice little tour to some outcrops around Oakley, Idaho. And I'm probably going to circle back at some point and maybe do a video on a couple of those. I got some things to figure out. I've got some ideas though. So Ken and Pocatello, Vancouver Island, very cool. Been there a couple times. Stan, thank you. Appreciate that. Education's awesome. The more you learn, that's just an investment in yourself. So we'll spend a few minutes just kind of killing time here. Make sure once we get going, any questions you have, if you can just put those in all caps, that'll help me kind of scroll through and find them. And we'll just see kind of where this goes. I've got a couple things I want to share on Iceland, but we don't need to spend all our time together with Iceland. And then we can just see what kind of questions you guys have. Good evening from Wales. I have been to Wales. Fascinating place. Snowdonia was really awesome. All the slate roofs that were around there, very cool. Rob, geology dude, that's a cool name. I should have grabbed that before you. John from Des Moines, welcome. And then a couple of people I think couldn't make it in, but sent me some questions or some topics to look at or to discuss. So we could also address those, including someone who just barely emailed me just in time with some outcrop out in the Mojave in California that they saw in another YouTube video that they want me to look at. Chris in Meridian, Idaho. David, thank you, David. Fun stuff. Great, yeah. So again, kind of free-flowing, open format. Questions you might have, I'll do the best I can. Could be questions about geology in general, specific places, how I make the videos, or something more about my background, if that's of interest. Doesn't have to be. And I'll just do the best I can. Obviously, there's only so much stuffed into my brain, and I'm always trying to learn more, but I'll do the best I can. Oh, another person from South Wales. Yeah, I got to get back there. We did a trip in 2016 with students we actually flew to Dublin, Ireland, took a boat across the Irish Sea to Wales and spent a couple days in Wales. A lot of the places we went to, I can't remember, but we went to like a Bronze Age kind of quarry. There was some really neat folded outcrops. I'd have to look at the notes and the maps, but we spent a couple days there, and then we took a train through England up to Scotland, which was really neat, to Edinburgh. So very cool. Yeah, Troy, Yeah, glad you appreciated the Bonneville flood. Geology dude is near Seattle. My dad lives on Whidbey Island in Oak Harbor, so occasionally we're up that way. Stan man, heat wave coming to Idaho. Yeah, I'm a little nervous. In 2 weeks, literally 2 weeks from, well, I guess it's less than 2 weeks now. On the 26th, I'm launching on a Grand Canyon trip, rafting trip. Um, and I'm a little nervous. It's like 115 down at Phantom Ranch at the bottom. So we'll have to see how that goes. It may just literally melt the camera and I can't do anything video wise. I'm sure that's not the case, but it's very hot down there and I'm hoping the monsoons kick up and I'm able to get down there and get to some of the places I want to go. Cherish Smith from Ontario, Canada. Hello. Michael George from South Africa. David Huber. Do I ever sleep? Yeah, I sleep well. I sleep 7, 8 hours a day. So I think sometimes for you viewers, remember that there's a lag time, right? So when you see a video of me in Iceland and then there's another one in Hawaii and you're like, well, what's going on with this guy? I already went there and I did the video, but I don't always post the video right away. So there's, some lag time there. I did have the Hawaii and the Iceland trips almost back to back, and I did a bunch of them in both locations. So you literally had a series of videos coming from both locations more or less simultaneously. So yeah, so I don't feel like I stay well rested. I don't feel like I'm overworked in any respect. So cool. 41 people. That's great. I'm sure we'll get a couple more here as we get closer to 11. Let's see what else. Let's see. I'll wait for the questions. I see the one about Baja, BC. Yeah, lots of raccoons at Phantom. Yeah, I don't think we'll be staying at Phantom. That's just the one place that has a weather station, so you can kind of get a sense for what the temperatures are like down there. I'm not sure where. If most raft trips, the way this works is like you kind of figure out your campsites as you go. So we'll just kind of see how it feels. Yeah, I back east, high temps with humidity is a whole nother game. I've pretty much always been a West Coast Western guy. I did live in East Texas for 2 years. I don't deal well with the humidity, but I can stand the heat. Before we moved to Twin Falls, I lived in Blythe, California. You can look that up if you want to. It's between Palm Springs and Phoenix. And we had 120-degree summers. And when we moved there, I thought, well, 100 degrees, 110, 120, it's all the same. And I realized quite quickly, there's a huge difference. Like 100 degrees is tolerable. You can do things, you can just be smart. 110, 120, like it is like survivor mode. Like it is just incredibly oppressive. And you cannot do much. Nothing cools off. Even like swimming pools stay at like 85, 90 degrees. It's just really hot. So hopefully the canyon though does cool off in the evenings. The water's obviously cold. There's side canyons with little waterfalls and stuff. I think we'll be fine, but yeah. And if I'm looking down, it's because I'm looking at my phone, because that's where I actually have the chat scrolling through. It's a little bit easier for me. Yeah, Vermilion Cliffs. Yeah, I might be down there. Probably this fall, I'll be down there. A couple more hellos to folks, and then we'll get started. Max Picks, Utah. Hello, Montana Rock Slayer. I love some of your names. I probably should have done something cooler creating my YouTube channel back in the day than just literally Shawn Willsey, which is as boring as it comes. But I didn't really know what I was doing. I didn't know what it was going to do later on. And so it is what it is. Brian E., thank you. You're here. And then Skagit Ed. Awesome. Great. Garrett. And from the Netherlands. Great. I've not been to the Netherlands. Thanks for joining us, Garrett. John from Washington. Brian is in Vancouver. Yeah, cool. So you guys can keep chatting with each other if you want. But I'll go ahead and get started, assuming everything still looks good. And what we'll do here is, let's see. Okay. Maybe just start with this Iceland eruption. Just quick background then, as many of you probably already know, but this area of Iceland, the Southwest Peninsula, what's called the Reykjanes Peninsula in Iceland, has largely been, even though historically has been quite active, it basically hasn't had any sort of eruption for the last 800 years until 2021. And so there was a big eruption there from like March, I think, to like September, about a 6-month window in 2021. And I watched with envy and thought, oh my gosh, I would love to be there. This is so awesome. But, whatever teaching obligations at the college here, finances, whatever, prevented me from getting there. And then that eruption shut down in September, and I thought, darn, opportunity missed. So then last year, 2022, when it erupted in August, I just had to go. And it was this perfect window where my wife was already starting her job with the school district. I had like a couple weeks until I needed to report back here at the college. And so we pulled together some money, went there. It was super bare bones. Some of you might have seen all those videos I put together. There wasn't any places to stay. Like all the affordable lodging options I looked at were booked. And so I ended up just camping on the ground or sleeping in the car. But it was totally worth it. And then so I was there about a week after the eruption started, and then probably another 12 days or so after I got back, that eruption shut down in 2022. So earlier this week, I guess it was Monday, an eruption began here in Iceland in roughly the same area, a little bit further north, still in the same region. And it's really, in terms of like tourist-friendly eruptions, other than the hike out there, which is a bit rough, I mean, this eruption is literally taking place 20 minutes, not the hike, but like, let's say 15, 20 miles, if that, from a large international airport. So really quite a spectacular location for this eruption to be taking place right there. Let me so this is a live view of the eruption right now. And so you can see that the eruption, which is mainly this fluid lava here, basaltic lava, is more or less confined to this primary vent. So it's building up a cone, what we would call at this point, we'll call this a spatter cone. The lava is pretty fluid. You can see a lot of the gases coming out with it and drifting down with the prevailing winds. You can also see that as the lava pours out of the vent, it's not only built up a cone, but it's overspilling the cone and forming a channel of lava, a river of lava that's flowing out. And most of that lava is moving to the south. And I'll show you some maps here in a second. So that's sort of the live view of what's going on there. And let me go to a couple other. Well, let's go back a bit. This is I didn't have as much time to organize this as I wanted, so forgive me if it's a bit helter-skelter, but this is actually earthquakes in the last 24 hours. And so let me zoom out so you get a little bit of sense of where we are. So here's the Iceland, the country, the volcano. And the area of interest that we're focusing on is this southwestern peninsula. Here's Reykjavik, the capital city. The airport, though, when you fly into Iceland, you actually fly in over here at Keflavik. This is an older, I guess, abandoned US Air Force base. And so when the military pulled out of there, I think in the 90s, that base and its runway and its facilities became property of Iceland. And so that's where they ended up putting in their international airport. So it's about a good half-hour drive from Keflavik, the airport, over to Reykjavik, the capital city. But this is where, as you look at the southwestern tip here, this is actually where the plate boundary between the North American and the Eurasian plate, this is where it comes ashore onto Iceland. And I've done a couple videos, maybe 3 or 4 from down here, real fascinating area. And actually, maybe we'll switch to Google Earth for a second. We'll do this in a minute. Let's get out of, I'll show you this later. This is one of the viewers had a question about this place in the Mojave. So let's head over to Iceland real quick. Get north, there we go. It's a little clearer view, I think, than dealing with all the seismic data. Let's take the roads off too. Roads are nice, and let's take the whatever borders are there. There we go. So you can see the white, those are ice caps. Here's the plate boundary again coming ashore. And what I hope you can see here is, as you look at the topography, you can see that there's ridges, mountains really, just mountains and hills that are oriented in this southwest northeast direction, and they're sort of stepping stair step style across the landscape here. Let me turn on the little pen here so you can see there's a section here. There's another one here. There's another big one over here. And so these are all part of the plate boundary. The plate boundary here trends in this direction, but it's sort of stair steps, what we call an echelon style. And of course, the spreading direction is perpendicular to that. So the two plates are spreading not perfectly east-west, but more northwest, southeast-ish here. And so if we zoom in to this part that's erupting, so here's a little fishing village of Grindavik. And then the 2021 eruption is all this black you can see here. So in 2021, it was quite close to the road. You can see the road here, and it was not a long hike to get into this lava field where this was erupting. And this was, I really wish I could go back in time and go, because this one I think was really quite exceptional. Again, it lasted 6 months, which was great. And then and then it shut down, so it didn't erupt through the winter of 2021, 2022. And then in August of last year, 2022, it started erupting again, more or less just to the north of this area. And so what I had to do last year was park down here and then hike in up some crazy trail up onto this ridge. These are clouds here, the white, so it's a little distracting. But the more recent eruption for 2022 was this northern edge of the lava flow here. And so what we have now in 2023 is, so we had the 2021 eruption here, the 2022, but the most recent eruption has sort of picked up where this left off more or less, and is taking place near the bottom of this hill and out across these plains. So there's a kind of a conical shaped, maybe I can zoom in and give you a little better view. It's very obvious from the highway as you head from the capital out to the airport. There's a nice cone-shaped hill called Kelir. I hope I'm pronouncing that right. And the eruption is sort of between this topographic feature and this hill down here to the southwest, which is called Litli Hrutur, which I think means little ram in Icelandic. And if there's any Icelandic speaking people, I apologize ahead of time. But across this vast plain here, this is where this 2023 eruption has taken place, and much more remote. So I'm hearing from people that are there that it's a good one-way 20-kilometer hike. They've got some access points, so you park down at the same areas I parked in, but then you have to hike. I think they're hiking in on the east side of this ridge, all the way around the old lava flow to get out to a viewing area here, or those who want to are heading out here. Now today it's actually closed. They've had, I'll show you some of the things going on there. The winds have been a little bit erratic. The moss there, all the green you see there, that is actually very thick, spongy moss. If you've ever been to Iceland, all those older lava flows in that very wet maritime climate end up developing very thick lava flows over the top of that. Oh, let's see, what are people saying here? Let me look here. No video? Oh, darn. Okay, so let me stop for a second. Can everyone see the Google Earth image okay? So maybe I screwed something up. Let's try. Oh, okay, darn, here we go. How about now? This is a lesson to keep looking. Let me know if you can see the Google Earth image now. Let's try. Are we good now? Okay, sorry folks. I just went off on like a 10-minute rant, and yeah, it's a bit of a three-ring circus because I'm looking at two screens, my phone's going. That's okay. Okay, so sorry about that. Thanks for hanging in there. Okay, quick minor recap, and then I'll get to what I was showing you guys before. So Iceland, Southwest Peninsula, the main tectonic features are these ridges and these eruptive vents that run southwest to northeast across the island. And those, of course, are perpendicular to the extension direction between the two plates. So the two plates are spreading something like this. And so that creates fractures and cracks where these things open up. So sorry, folks, not a full-time professional live streamer, apparently. Fishing town of Grindavik, the 2021 eruption site was in here. The 2022 eruption site that I visited was in here. And so the 2023 eruption now is moved a bit north. So you can see, based on these three events, which I don't know if we should read into that too much, but we might, that it's moving to the north and it's occupying, the fissures are now in this flat-ish area between these hills here. This is Litli Hrutr, and this is Kelir, this sort of cone-shaped mountain. This is a Tuya. So this was a subglacial volcano, this cone-shaped one here. So this is where the eruption site's taking place now. Okay, cool. Moving on. Lost my train of thought. So that's just the lay of the land a little bit. Oh, the moss. So this is all mossy ground here. I want to show you a couple of videos that shows what's going on here with the lava and the moss, because even though it's quite the moist climate, they've had a dry spell. They haven't had rain for a few days, maybe a few weeks. And so the moss is actually a little drier than it might normally be. And so the moss is actually catching on fire. And I guess it's a wildfire, essentially, right? It's not trees, it's not grass or brush per se, but it is vegetation or flammable plant material that's kind of moving across that area. So if we go to the videos, let me pick one of these to show you here. No, let's see. Can I move? Oh, there we go. Let me move this down here. Here we go. So this is a video. This gentleman lives in Iceland and does a good job of documenting lots of the eruption footage. You can see the fissure back here, but more importantly, in the foreground here, you can see the moss actually burning. So I'll just let that go for a minute, and you can see some of the moss burning. So that's what's creating a lot of the smoke. So a lot of the hazard in the area is partly volcanic gases, but it's also partly the smoke from the moss burning and then that moving downwind as well. And you can see some of the people standing there. So that's different. That, to me, that's kind of interesting. When I was there, the moss was still quite wet. It was rainy. And so you didn't see this quite as much. That gives you a nice view of what this moss looks like. It's really kind of cool to walk on. It's very spongy. But it looks like it's pretty dry right now, and that's why it's much more flammable and catching on fire, at least at this time. So, okay, so that's what's kind of going on now. Let me back up a little bit and go back to this. This is a map showing the last 24 hours of earthquake activity. So this is the Icelandic, one of the government websites that tracks earthquakes. And to give you some context here, the main area that's erupting is more or less in here. But what's interesting is that the volcanoes erupting here, but just to the south of this cluster of green dots, but the volcanoes erupting here, but the earthquakes are to the north. So this might be suggesting, again, just putting on my geology interpretation glasses for just a second, that the fracture, the dike, the conduit of magma that's rising towards the surface along this crack, it could be opening to the north. And so these earthquakes are all clustered around that cone-shaped hill I showed you called Kelir. Again, doesn't mean that it's going to erupt, but potentially the magma is intruding out in front of the fissure and it's opening up kind of like a pair of scissors. It's opening to the north. As that magma is pushing into that rock, it's cracking and breaking the rock, and that's what's causing the earthquakes there. So we've lost the earthquakes have dropped in the region where the eruption is, because the eruption now has broken more or less all the rock it's going to break. There's a clear conduit to the surface. And so there's no longer a lot of earthquakes happening there. And so the earthquakes are more or less running to the north here. So it'll be interesting to see how this goes over time. Some other cool data. Oh, this is pretty interesting here. So this is the, again, Icelandic government. It's a little trickier to figure out things versus in Hawaii, because it's a different system. The USGS system I'm quite familiar with, so I can find all the data I need to. And then you go to another country's geologic monitoring system, and you've got to kind of learn the ins and outs of it. So this is here. This was leading up to the eruption. I don't know if I can make this bigger. Can I? Oh, good. Perfect. This is interferometry. So this is basically ground deformation. So each band of color is a change in elevation. And what this fundamentally shows, you can actually see running northeast to southwest, right through here. That's the intruding magma body coming up and displacing the land on either side of it. So the land on either side of it is actually inflating or moving upwards in response to the injection of magma. And so what this shows us is that even prior to the eruption, if you were watching this area, there was good indications it was going to erupt, because the earthquakes and the ground deformation were pointing towards magma had moved into this shallow subsurface. It was causing the ground to inflate and sort of bulge outwards, if you will. And all of that, the Icelandic government knew that an eruption was basically imminent. They didn't know, what day or time it was actually going to erupt, but all that was pretty well predicted. So that's a nice little bit of data there with this ground deformation showing the intrusion of the magma. And you can see it moving from the old volcano, which is Fagradalsfjall. I probably butchered that, towards Kalir, okay, that little area there. And then this one here, I don't think this one enlarges, but this diagram here shows earthquakes. So you can see earthquakes on the 9th of July, up and down, a big spike on the 10th of July. And then again, as that magma is moving up towards the subsurface on the 11th of July, which was just the day it erupted on Tuesday, that magma pushing its way closer to the surface, cracking the rock, generating the earthquakes. And you can see all the earthquakes that happened during that period there. And then a nice map here. This one might enlarge. Oh, no. That shows a little bit more of the topography. So there's the old eruption from 2021, 2022 in purple. And then the orange is not lava necessarily. This is just what they call the hazard area. The intrusion of magma in blue would be based on that first diagram I showed you with the psychedelic pattern, the ground deformation. And then the red line here is actually where it broke the surface. So what was predicted based on ground deformation, and then what actually took place, and pretty good agreement there between the two. Okay, so that one's helpful. Again, there's a live camera. They've got a webcam up there, so if you're really into this stuff, you can watch it take place. This was a guy, a drone from a couple days ago, I think, and so this is a nice video just showing sort of the type of eruption we're talking about. Again, a fissure eruption. This is how it began. So this video is from the 10th. So yeah, that was a couple days ago. I guess that was Monday, the day it started. So that was the first day of the eruption on Monday. But if it started out this way, and this is typical. So you can see one fissure here in the middle of the photo going off to the left, and then another one kind of behind it that extends to the right. So these sort of offset segments of fissures. And so you'll get erupting magma occurring along those for some period of time. But then what typically takes place is as these fissures, there's some of the lava there, but as these fissures erupt, eventually parts of them get clogged, the plumbing system gets a little more organized, and then it more or less oftentimes coalesces to a primary vent or sometimes a few vents where the eruption's taking place. So I'm just skipping through this, but there's Kalir, there's that nice cone-shaped mountain that the volcano could be moving towards if the magma supply stays at a high rate. But again, you can see the fissures there. So that view is more or less looking to the north. Now he's swinging around a little bit to the northwest. You can see a lot of the lava is flowing down to the south, which is good news for Icelandic people, because had these flows been moving off to the north, if you remember back to the Google Earth image, there's that highway from the airport to Reykjavik. So if this volcanic eruption was moving down a slope moving to the north, we could see a much bigger impact on infrastructure and disruption of that. That would actually be, I don't know how they would deal with that, because the airport's there and you'd be cutting off the primary route between the airport and the main city. There are routes that go around that you could take, but those are many hours longer. So it would be a big deal. So props to this guy, Isaac, for great footage of the eruption on day one. Then, oh, this one's pretty cool. Let's do this one. So this is one. So this is another, so this is Jacob. And this is another drone shot. You can see the main fissure here. And I think this is, when did he take this? So this was the first day too. So this was on Monday. You can see the main fissure here. But what I want you to watch is on the left side of the diagram or the photo or the video, you'll start seeing little bits of steam. You can see a little bit right there on the left side. Now watch it grow. This is basically a second fissure opening up in real time. It's getting bigger. You're burning more of the moss. So we've got gas and maybe some smoke coming out. We can't see if there's lava right just yet, but it's got to be pretty much right there at the surface. And then let me pause it right here. There's another secondary spot right in the middle of the frame where it's opening up as well. So basically he had a really good fortuitous instance here of documenting a fissure erupting in its first initial minutes, which is just really spectacular. And then here he is. I mean, he skips ahead a little bit here, but now you can see the fissure almost connected, forming a through going feature. And then I believe in a couple seconds here, we should see our first little chunks of lava being pushed out. And so you can actually see that this is indeed a new eruptive fissure. So again, the rock is being split open as the pressure from the lava intrudes and pushes that to the surface. And I don't think since it's a drone, there isn't any volume. Boom, right there. Did you see that? Let's go back. That was really exciting. Look right in the middle, and you could see it blow out and create a primary vent right there. So that was lava being thrown out, a little minor fire fountaining, and now we're seeing the lava. Now the vent has cleared a path to the surface. And now again, you can see these two vents here. That cone-shaped mountain is either, I think it's off just to the right here, but there's the primary vent. So again, this was all the first day. So appreciate all the great footage, and you can get onto YouTube just like I did and find all these things. We looked at the fires there. It's worth noting, in case anyone on here is actually in Iceland, that it's actually closed till at least tomorrow. They base that on all sorts of conditions, weather factors, what's happening with the volcano. It's a long slog out there. The Icelandic government, I'd say in general, is really good about just letting people appreciate the volcano. If this was happening in the US, not to make this weird or whatever, but I think there'd be a lot more regulations and closed areas. But in the Icelandic culture and their government, they recognize that volcanoes are beautiful. There's something everyone should behold if they have the chance to. And they basically do everything they can to let people go access those volcanoes when they're erupting, as long as it's reasonably safe and people understand the hazards. So they're basically saying, hey, it is a long hike out there. The terrain is difficult. The weather is nasty. And you're kind of on your own. But if you want to, and you want to head out there, you can. But for today anyway, the site's it closed the access to it. Let's see. So we looked at the earthquakes. I think that's all I've got for the Iceland volcano. Let me look at the chat here and scroll back, and maybe we could just start with some questions about this section here, Iceland, before we just open it up to anything under the sun. Let's see, what's my favorite? I'm just starting part with you. From Nancy, what's your favorite Iceland live stream channel? Preferably with some drone shots. Oh boy. So this gentleman here, I've probably used his the most. So he goes by, and I don't know if this is his name. I don't think it's his name because Guten Tag. So he's got drone shots. He's definitely a YouTuber. He's got a lot of followers, and he's been able to get out there quite a bit. So if you look at the videos here, there's 4, 8, 12, 16, I don't know, upwards of like 40, 50 videos since this eruption began this week. And maybe that's overkill, but the nice thing is they're relatively short and you can pick and choose your way through them. Now, he's not a trained geologist. He just recognizes that it looks pretty. So not much insight in terms of the geology, but he does a pretty good job of just showcasing it. So if you just want to see some nice eruptive footage, I'd say start with him, and I'm sure there's some other ones as well. So let's see, scrolling through. Difference between a spatter cone and a volcano from Troy. A spatter cone is a volcano. A spatter cone, if you know your volcano types, I would say a spatter cone fits between, gosh, a spatter cone would be a non-explosive. If a spatter cone is erupting, I would like to be as close as possible. It's erupting fluid lava. It's basaltic, but it has a little bit of gas content to it. So it's actually throwing clots of lava into the air, piling up around the vent. But it's not as frothy and gas rich as a cinder cone, if that makes sense. So it would be sort of between a fissure eruption and a cinder cone. Basically, if you can get a fissure eruption to concentrate its activity in one vent rather than forming along that crack, that split through the earth, that would eventually create a spatter cone. And spatter cones don't tend to be very high. They could get up to maybe 100, 150 feet. The one we saw in Hawaii was probably 150 feet tall, maybe I don't think it was 200 feet, but on that order there. So hopefully that kind of makes sense. Good question. Okay, and then everyone was having trouble with my technological issues. Okay, but we got that fixed. And scrolling down, just looking for caps. Yeah, I was in a zone. Thank you, David. I was in full lecture mode there. Is the Iceland hotspot contributing at all to these recent eruptions? Oh yes, undoubtedly. Now, Iceland is an interesting location because tectonically and volcanically, it's two things. It's well, okay, I think I get Dan's question better now. The actual hotspot beneath Iceland, based on subsurface geophysical information, is more or less over here. It's more or less under the south central portion of the island, as far as I know. And so most of what we're seeing here is a result of the tectonic activity. So the fact that this plate boundary that's splitting these two plates apart comes ashore, that's actually what's causing most of this volcanic activity. So it's the fact that we've got these, again, these cracks, these fissures that have formed in the past, right? So all of this activity here is related to the two tectonic plates spreading. So that would be my take on that. Hopefully that helps, Dan. Really good question, and hopefully I understood your question well there. Is lava, from Greg, my friend in Tennessee, is lava reaching the moss, or is it heat underneath causing it to burn? I think it's mainly the former, Greg. I think it's mainly lava, the edge of the lava flow, and we can maybe go back to one of those videos. I don't know how helpful that would be. But the edge of the lava flow reaching it. Let's see, maybe we could find one of these quick ones here. Yeah. Oh, we got to do the ad. But I think it's the edge of the lava flow reaching the moss and burning the moss that's in contact with it. So even though this one, you look at the moss there, you're like, why is that burning? I don't see any lava next to it. I believe there's the lava has been up against it. Because the heat from underneath would be pretty localized. I think it would mainly be near the eruptive site. So I think as the lava flow spreads out from the vent and the fissure, that's where you're probably burning most of the moss. And because the lava spreads in such a big so many directions over such a big area, you can burn a lot of that moss and therefore generate a lot of that smoke. So hopefully that's good question, Greg. Hopefully that helped a little bit. Let's see. I'm just looking for caps. So if you did something from Troy, is this how craters the moon look during its eruptions? Absolutely. If you look at craters of the moon, if we leave the North Atlantic and come across the pond and head into my lovely adopted state of Idaho, you can see a similar thing. So now we're looking at a landscape that's not erupting right now, but did erupt a few thousand years ago. And what you can see on this landscape is turn on the annotation thing here. You can see a similar sort of thing with these fissures that run southeast to northwest across the landscape, right? And so so we come up here to where most of the area is, or you can actually see these, right? You can see the alignment of vents pretty well too. So for example, turn this back on. You've got a volcano here. You've got a volcano here. There's one there. There's one there. And so they're following this northwest southeast trend. And in places you can see the cracks in the ground where the fissures have erupted. Oh, this is great here. This is so here's these cones here. These are actually spatter cones right here. So if we had a question about the spatter cones, let me change the view a little bit so it looks a little. You can park right there and hike up right up to these spatter cones. Let me swing you guys around. Hopefully this works. Yeah, a little bit grainy, but hopefully, yeah. So this isn't very tall. This is maybe it's 6,000 feet there. Yeah, this is like 30, 40 feet tall. But these are spatter cones that formed along an eruptive fissure. So you can see the crack in the ground more or less here. There are some spatter cones here. And then you can actually take that even further. And then there's some bigger craters along that trend as well. So yeah, absolutely. Craters of the moon, very similar process overall, at least in terms of that eruptive style that we're seeing in Iceland right now. From Can, how big were the Columbia River basalt fissures relative to Iceland? Well, way bigger than the ones we're seeing today. So if you were to compare the Icelandic fissure, which I guess I didn't give you measurements there. I think they're about, don't quote me on this, but they're a kilometer or maybe two long, so a mile or less in terms of their total length. Whereas the Columbia River basalt fissures, it's hard to know that it was a one through going fissure, but in terms of like where the fissures began and ended, some of those are tens of miles long. So much longer and much greater volumes of lava pouring out of the Columbia River basalt eruptions versus what we see in Iceland. So let's see. Oh, Troy, thanks for the donation. Appreciate it. Awesome. Great. I think that caught up with most of the Icelandic questions. So hopefully that helps. Again, I'll kind of keep, if anything remarkable or different happens, I'll maybe do another live stream, kind of like I did with the Hawaii ones. I got real excited with the Hawaii ones just because I think I'm connected. I have a personal connection to both locations, but my Hawaii connection is a little longer and a little stronger, I guess. But having been to Iceland now 4 times, I feel like it's a place I definitely keep tabs on. So awesome. Okay, let me go. There was a couple questions at the very beginning that were more general in nature. So let me grab those so I don't lose those, and then I'll come back down to the most recent ones. Someone asking me about the Baja BC thing, scale of 1 to 10. I know you're referring to a lot of the stuff Nick Zentner's been doing. And I know Nick, and he does great work. I'll admit, though, that I don't have the time to follow all of his stuff. That guy's prolific. He does a lot. Someone asked, when do I sleep? When does Nick sleep, right? So I'll probably give an unsatisfying answer. I don't know enough about, I haven't read enough and learned enough about the whole Baja BC issue to have a strong opinion. So I guess I'm a 5, right? Right in the middle, because somewhat neutral. I actually did work, my graduate advisor was Paul Umhofer, who passed away a couple of years ago, unfortunately. And he was one of the people Nick's talked about that worked a lot with the Baja BC thing. Interestingly, though, I actually did my undergraduate research down here in Baja, just west of this town of Loreto, in these mountains here. But it had nothing to do, the research I did had nothing to do with Baja BC. The research I did was much younger, 6 million year old tectonic story, that sort of thing. So sorry, I don't have a strong opinion on that. There's so much geology to learn. Ken asked me what got you started in geology. Great question. So I went to college and had no idea what I was going to do. I knew college was important. I wouldn't say obligated. I felt compelled to go further my education. At that time, neither one of my parents had been to college. My dad was in the Air Force. He did go back and get his degree, but my mom didn't have a degree. And so I just went to college because I thought, well, that's what you do. And for 3 years, I had really no direction. I took a forestry class one semester because I thought, well, I like being outside. And forestry sounds outdoorsy. And we went on a field trip up in the Uinta Mountains, and it was a beautiful day. And our professor had us measuring trees, diameters, and we were doing lots with the trees. And I remember thinking, this is nice. I'm enjoying being outside and I appreciate trees, but I'm really not that interested in trees in terms of like this level of scrutiny. And so my 3rd year in college, I don't even know how or why it happened, but I ended up taking Geology 101, physical geology, and I really liked it. And so I took the next class, and then I took the next class, and then I realized you could major in geology, and so it just kind of snowballed from there. But as a kid, I was always interested in maps. I remember just going on long drives with my parents, or when we were moving around the country from Air Force base to base. Just like, before you had devices and movies in the car you could distract yourself with, just looking at a map and looking out the window at a mountain range and like, okay, that's that mountain, and I wonder where that river goes, and just like really being interested in landscapes and topography. And so I think that's probably where a lot of that interest kind of came. And so anyway, so then I majored in it, got a bachelor's degree, went to graduate school in Flagstaff at Northern Arizona, got a master's degree, and then at that point I'm married. I was going to do a PhD, and my wife said, let's pump the brakes a little bit. You've been in school a long time. It'd be nice if you could like contribute to the household income, which I agreed with. And a PhD was a bigger commitment, but I was looking to go to UCLA and working with a professor there on some more tectonic research. So I said, well, okay, yeah, let's try just working. And so we moved back to Utah, to Salt Lake City. At this point, my wife's pregnant, she's working. And actually my first 2 months out of grad school, I couldn't get a job. Like I was unemployed, which kind of embarrassing. Eventually I got on with a groundwater consulting company. Now, I had never done any groundwater work in grad school. I hadn't taken any classes in hydrology. The guy that hired me, though, because I'm a structural geologist that's my main, that and volcanology are probably my 2 expertise. And he told me he was doing projects in very structurally complicated areas. So he needed someone that could understand the structures. And he said to me, well, it's easier for me to teach a structural geologist like you hydrology, excuse me, than to teach a hydrologist structural geology. So one of the first things he had me do was draw cross sections so that, I'm trying to figure out, are the rocks folded? Where's the fault? How do we get to the aquifer? And I loved what I did for those 2 years. It was really fun. The technical aspect of it was great. It was rough at first because it was like direct time job. So you had to like bill all your time to a client. And so there was always this stress of like every minute of the day had to be accounted for. But I liked what I did, but I looked up the food chain and I thought, man, where am I going to be in like 10 years? And I realized that the progression in that company was you start at the bottom doing science, but then as you move up, you become more of a manager, you're writing proposals, you're managing employees and budgets and that sort of thing. And I'm like, that's not what I want to do. I want to do geology. And so that's when I started teaching part-time at Salt Lake Community College, realized that was my passion. Then started applying for full-time teaching jobs. And the first one I got was in Blythe, California, which is located here in the middle of the Colorado River Desert on the border between Arizona and California. It was a rough place to live, 120-degree summers, tiny town. It was a growing experience. Great geology, though. I would take my students on field trips over to the San Andreas Fault, the Salton Sea. But we stayed there for 2 years, and then we came here to CSI. So anyway, probably a long-winded answer there based on what you're asking. All right, let me catch up and get back to the more recent part here. Is craters of the moon due to... Oh, wait, there's one before that, sorry. Where and this is from David, where and at what age did you recognize you were fascinated with geology? Okay, I guess I answered that. As a kid, I was into dinosaurs and maps. That was probably, I think I took an 8th grade earth science class that I really liked, but you kind of forget all that in college. Like I didn't remember that, oh, I like this thing. So I had no idea, I think puberty and adolescence just, mushes your brain up a little bit. So probably wasn't until I was in college that I really realized this was what I wanted to do. Diana, why are most of the fissures opening south of the plate boundary and none north? I'm assuming she's referring to the Iceland stuff. Most of the fissures opening south of the plate boundary and none to the north. Not sure I totally get your question, Diane, which is probably on me, not you. If you're talking about this one eruptive fissure, or if you're talking about like in general, the plate boundary is right here. It comes ashore. I mean, if you were just to draw a line for the plate boundary across here, it would look something like this, right? Like here's the plate boundary in Iceland, and then it goes off and goes up this way. But that's a bit of a lie, because the plate boundary is segmented in ways. So there's like a little segment here, then there's one here, and one there, and one up here. And so they all collectively are tied together. So probably didn't answer that well, sorry. Is craters of the moon due to, this is from John, CRU? Crap, I don't know what CRU means. Yeah, I probably know what that acronym is, but it's not jumping out at me. Looks like David answered you maybe anyway, so that's good. Oh yeah, David's always good about kind of helping me answer these questions. So could you do a video on the twisted rock layers in Provo Canyon? Yeah, there's some cool folding, mostly from the severe orogeny about 70 to 100 million years ago in Provo Canyon. That's in Utah, if you're not familiar, but there's some very cool folded and twisted rocks in that area. Definitely, we have family down in that area in the Wasatch region, and there's so many more videos I could be doing down there. So I will try to do that soon. In your opinion, where would the next volcano go off in North America? Huh, from Jesus. Really good question. Does Hawaii count? Oh, in North America, right? Well, if you're talking the entirety of North America, then my money would be on Alaska, which kind of always has little volcanic activity, or something in Central America or Mexico. I'm guessing that you might be thinking more like continental US. Definitely, I would say one of the next volcanoes I would expect to erupt, possibly in our lifetime. I mean, none of them are showing signs. I guess St. Helens, it's done it twice in my lifetime, so why not another one? It's definitely shown a history. If you go back the last couple thousand years, it's a very active volcano. So I would go with Mount St. Helens doing something before any one of these other ones. But it could be a Cascade volcano, could be it craters the moon. What I don't think is it's not Yellowstone. Like I would put $100 on the table, which is a big chunk of money for me, and say Yellowstone in my lifetime is really, really low odds. It's just a bigger system to erupt. There's good evidence that the magma beneath Yellowstone has partially crystallized. I'm not worried about that at all. But a Cascade volcano, yeah, those tend to erupt on average. You know, one of those might pop off every 100 years or so. So absolutely. So yeah, good question, Jesus. Let's see. Michael's dad was in the Air Force too. Air Force brats, all of us. Mike, thanks for the donation. John, an Army brat. Let's see. What are your thoughts regarding tomography? Will it revolutionize our understanding of deep time and slab history? Yeah, I think the cool geophysical tools, LIDAR, seismic tomography, like all these things are definitely helping us unravel some of these big questions, right? It's helping us gather more evidence. Geology is complicated. Trying to figure out these big picture stories. We've got billions of years of history, lots of landmass, lots of things that have happened over time. And so the more evidence we can collect, the better, especially that deeper evidence, right? We can pretty well figure out what's happened at the surface, and even that's sometimes difficult. But I think things like tomography that can actually image these subducted slabs and show us where they are beneath continents has totally, and I think will continue to revolutionize like our thought process and understanding of things. So let's see. Are you thinking, oh, just skip down. Are you thinking about any more Yellowstone videos? Really appreciate your hike to the Unconformity. Yeah, at Mount Everett. Yeah, that was a big hike. I had to wade a stream, the river, because the bridge was washed out from the flooding they had the year before. That was a butt-kicking hike, but I'm happy to do it. And I knew once I got up there, it would be worth it because I knew it was going to be good. I don't have any plans to do anything in Yellowstone anytime soon. I did a couple just outside the park, and I've got one more coming in the next week or so about the Henry's Fort caldera, which is the second youngest caldera eruption associated with the three big ones at Yellowstone. So to answer your question, I don't have any travel plans to go to Yellowstone anytime within the next year that I know of. We went this winter, so I feel like I kind of have done a lot of the really good low-hanging fruit locations in Yellowstone, like relatively accessible. So nothing on the horizon. But if you have like a couple cool places of interest, or you think there's a good geologic story here or there, I'd be happy to add that. It's pretty close to where I'm at. It's like a 5-hour drive, so it's not that far away. Diane, are you keeping up with any of the data from Mars's volcanism? Diane, I don't know anything about Mars other than it has big volcanoes and it had water at one point. So my planetary geology knowledge is quite limited. Sorry about that. Let's see. What's happening with magma chambers in the Pacific Northwest now? That's from Can. Well, you can get on, just like I can, getting on the Cascade Volcano Observatory website and looking at that would be a good way to go. I don't know if I can do that real quick on the fly, but like in seeing what we would expect to see first, if there was any sort of activity, the earthquakes are generally a good place to start. And I'm not on this one that often, so I don't know. Might be muddling my way through this. Earthquake information on. It's not really showing me anything, but maybe I'm not doing this right. Anyway, there you go, monitoring. So you could check here to see what's going on. What we're waiting for magma to rise. Probably the magma underneath Mount St. Helens is still there. It's just not eruptible magma. So to make magma eruptible, we would need to increase its gas content, which generally would mean we need an infusion of more magma. So at that subduction zone, we would need magma that's being generated at depth to rise and get closer to the surface. Now, in the process of doing so, that magma, as it's rising, should be creating earthquakes, little tiny earthquakes, breaking rock as it moves through the crust. And so that's what we would expect to see. And St. Helens being sort of the restless teenager of all the Cascades is the one that I would expect to see something happening with sometime soon. Could be like Three Sisters or something like that. Could be another one, but yeah. So that's what I'd look at. So you could get in here and look at all the monitoring data and see if there's something there. So hopefully that's helpful. And good question. Brian, your school and career path parallel Nick's in many ways. Yeah, I met Nick once. He grew up in Wisconsin and then came out west. I think we both have a similarity in that we're both, I think this is a big point to make too. We both have master's degrees, but not PhDs. We both, our jobs, for both of us, our jobs involve teaching as a primary focus. Now he's at a bigger school, a university, but he's the one of the faculty there that they've designated to teach geology, and mainly teaching undergraduate beginning classes in geology. And I do the same thing here at the College of Southern Idaho, where we're a 2-year community college. My job is not to take geology students and take them through advanced level upper division classes as they prepare for their degree. My job is to educate students who are not even interested in geology. They're just taking a science class. I'm here to give them a different perspective on the world, make them better citizens, maybe things like where you build your house, what things you might look for in terms of mass wasting, understanding how science works, what it can and can't do, understanding how this planet of ours works in terms of natural processes. And then along the way, I tend to get a few students who realize that they have a passion for this sort of thing. And for some of them, that turns into an education and career path. And for some of them, it just turns into a hobby, right? So for many of you, geology is something you're interested in. And it's a hobby. You're not going to school for it. You're not feeding your family with it. Yeah, so I think Nick and I share somewhat of a similar background. Neither one, although we've both done research in the process of becoming geologists and going to graduate school, neither one of us is engaged now in actively researching an area and publishing papers and doing the typical geology professor cycle that so many people do. And I don't have a problem with that. That's just not my passion. My passion's in getting geology to as many people as I can, because I think the Earth is fascinating. I think there's a lot of people that are interested in it. And I think we haven't historically done a good job of conveying science to the general public in a digestible way. So I don't think we've done a good job. I think the geologists know all these cool things have happened because we publish papers and we go to conferences and we collaborate, but we don't do a good job about educating the general public on all these amazing stories that the Earth has for us. And so I think, yeah, there's some similarities there. And he's got his style and I've got mine. I'm not trying to be Nick Zentner, and I'm sure he's not trying to be me. And so I see what he's doing. And sometimes I think, oh, that's a cool idea. Maybe I could kind of use something like that. But for the most part, I'm doing what I think is effective, what brings me joy, and what I think is a benefit to people. And I think he does the same thing, and it's just in a different way. So anyway, that's probably more than you were asking. It wasn't even a question, it was a statement. Geology dude, what is the most interesting geologic place in Idaho if you're not a geologist? So I guess the question is like a place in Idaho where you could take a non-geologist and they would be like, this is cool. I mean, Craters of the Moon, if you've never been to Hawaii or seen lava flows that look pretty fresh, Craters of the Moon knocks a lot of people's socks off. If you're coming from the Midwest, Florida, someplace like that, you go to a place like Craters of the Moon, you're like, whoa, this is a crazy landscape. Other places I can think of. I mean, just locally here around Twin Falls, there's some really cool places like Box Canyon. Now, this doesn't look like much on Google Earth. Here's the Snake River. But there's a big spring, one of the largest springs in North America, comes out of the back of this thing. You can see the kind of blue-green water here. So this is part of the aquifer. And it's crazy because people just park here and you don't even know what you're seeing until you walk right up to the rim. So until you actually get right to the edge here, and then gaze down on this thing with this, I mean, it's just this lush green. I mean, that water is like 30 feet deep, but it looks like it's 5 feet deep because it's so crystal clear. I mean, the topography is flat, right? I mean, look at this landscape, but then you get this crazy boxed in canyon right on the rim there. There's just places like that, places where people like, I had no idea this was even here. And so that's kind of fun. So that's a couple things there. I'll try to keep my responses short so I can make sure I answer it one. Anne asked, what about Rainier going next? Maybe. I don't think, I don't know enough about the Cascades to speak definitively. So your you know, opinions are like belly buttons. Everyone's got their own. Rainier, though, there's a good argument to be made that Rainier is the most dangerous volcano in America, not because it's the most explosive or it's the one that's going to erupt next or it's showing signs of activity, but because it's the volcano with the potential to affect such a big population. And so you've got Tacoma and some of these communities here along these river valleys, and it wouldn't even take much of a large eruption at Mount Rainier to cause flooding, lahars, possibly ashfall, that would impact literally millions of people. And so, I mean, St. Helens is here too, but if you really look at St. Helens, it's kind of isolated. I mean, there's a few little towns near here, but the big urban areas are pretty far away. Same with Adams, even Hood to some degree is kind of isolated. So I'd say, yeah, Mount Rainier's got some, you know, Rainier going next, maybe, but probably low chance in our lifetime of any one of these Cascade volcanoes having a big eruption, you know, in 1980, Mount St. Helens or bigger. Chances are low, right? There's bigger things to worry about, but it's interesting, right? On one level, we'd like to see that as geologists or geology fans, because it would be of interest. I think the area, there's been times in the last few years that the Three Sisters near Bend have shown some signs of activity. So that's another one to think about maybe too. David, what's the most geologically diverse place you've ever been? That's a good question. And I think about that because for me, geologic diversity would be lots of different rock types, lots of different processes, different stories. One place that just kind of came to mind, and maybe it's because my wife and I, we don't have anything there, but we bought an 1.5 acre property north of St. George. But this area here in southwestern Utah, this is where the Colorado Plateau, so all the red rock country and the sedimentary rocks, meets the Basin and Range. There's, so literally within like, you know, a few 10-mile radius around this region here, around near St. George, there's volcanic rocks, there's intrusive rocks, there's metamorphic rocks, there's faulting, both compressional and extensional, there's volcanoes, there's sedimentary rocks, there's fossils, there's really old basement rocks, there's really young, I don't know. So that might be one place that I might think about as having a lot of diversity. I'm sure there's other places as well, but that's one of the first places that came to mind. So good question. I like that one. Michael George says, have you visited or done some research into the Karoo Basin? No, that's in South Africa, I believe. And I have not. And South African geology and fascinates me, but I don't know that much about it. I'd love to go. Let's set that up, Michael. Glad you like the video series on Antelope Island. That's one of my places I like. John, thanks for the donation along with Troy. Jesus, what about a video about Mount Shasta or Medicine Lake volcano? Okay, Jesus, get excited because this fall I will be doing a trip out to, I'll go to Bend. I'm gonna do some stuff around, there's some videos around there. I'm gonna head down to Crater Lake, and then I'm gonna head down to Shasta and Lassen and that area. So I hope to do some stuff there. Do I know a lot about that area's geology? Not really. I've done a little bit around Bend. I took students there years ago. So I got a lot of research and reading to do. And so you find folks can always help me if you know really good outcrops. So what I'm looking for is a location, if you can give me GPS coordinates or really detailed information. But what makes a good video to me is a place I can show, I can access it, I can show it, and it has a good comprehensive story that I can tell and show to you as the viewers. So, and sometimes that's just one rock type, a bunch of columnar basalt. That's a cool story, might be. Sometimes might be more diversity with faulting. It just depends. So, so I'll do some research and try to find some places there. But definitely if you have some information on some of those locations, that can help. Troy, what created the Wasatch Fault and its small seismic activity? All right, that one I do know a lot about. So the Wasatch Fault, let me turn on the pen tool again. The Wasatch Fault runs pretty much through here, right about to there. It's probably one of the longest. It's in segments though, so it actually there's like a little segment here, and then there's one at Provo and Salt Lake City, and there's the Weber segment and the Brigham City segment, and I can't remember what the one to the north is called, but then the next one up here. So basically what's happening from the Wasatch Range over to the Sierras is this whole section of the earth is spreading east to west. So this is what's called the basin and range, okay? So this whole area here is spreading. Why is it spreading? I'll probably I do have plans to do a lecture video on the basin and range, but in a nutshell, as the Pacific plate moves in that direction, it actually pulls along the edge of North America, and so it tugs it a little bit this way. That's one idea anyway. There's a couple other ideas as well. But to answer your question a little more succinctly, what created the Wasatch Fault? Extension. East-west extension, pulling western Utah to the west, making Nevada get bigger. So Nevada has actually grown over time. So here's a good little real estate tip for you. So pay attention here. Go anywhere in the basin and range and buy an acre, okay? What will happen to that acre over the next, if basin and range extension continues, which we know it's going on right now, so why wouldn't it go on for at least a while? That acre that you buy now in 2023, at some point in the future will have grown and stretched to maybe like 1.5 acres. Now that's going to take some time. That's going to take possibly tens of thousands, maybe a million years. So you won't be around to reap the financial rewards. But if you leave that in a trust with your grandkids, great-grandkids, great-great-great-great-great-great-great-great-grandkids, they could maybe pay it, cash in on that. So kind of silly there, but yeah. Yeah, and then we did have an earthquake in this area in 2020. So in April of 2020, there was an earthquake, 5.7, I think, that was located kind of out here near the airport. And this is the main Wasatch Fault. But what you don't see here is there's some smaller faults that run through the valley too, and there's even some faults that dip this way. So this fault dips in this direction. So it's the mountains are going up, right, and the valley's being dropped down, if you will. I don't have a cross-section view, but that's the idea. So yeah, so we expect more earthquakes here, right? And we got one in April 2020. That same stretching east-west goes up into Idaho. You can see Mountain Valley here in southeastern Idaho. So this is earthquake country for sure as well. The Snake River Plain disrupts that pattern, but if you go across the Snake River Plain, you see a mountain range and a valley and a mountain range and a valley. And we had a big earthquake here in 1983, right about here, the Bora Peak earthquake. So that was along this fault here. This is the Lost River Range. The highest point in Idaho is about here, Bora Peak. So there's faults that run along these mountain ranges here, but they extend further to the west as well. So there's actually a large fault system running along the base of the Sawtooth Mountains. And in March of 2020, just before the Utah quake, we had a quake here in Idaho that was 6.5 that was located here. And I've done some presentations, and those are on the YouTube page about those as well. So very cool. Cool. More questions. I'm glad you guys are sticking around for this. Hot out there. Might as well hunker down, right? My blue schist specimen has yellow crystals in it, seen when enlarged. From Leslie. Citrine. Could be. I'd have to see a picture. Blue schist is usually in metamorphic rocks. Quartz can be in anything. So if it's kind of yellowish, Leslie, and a little translucent, like the color's getting into it, then it could be citrine quartz, which is what you thought of. Awesome. Let's see. Any other questions as I scroll down? Hey, Jesus, thanks for the donation. Much appreciated. Yeah, so okay, I'm catching up to where we're at here a little bit. Crater Lake. Someone named Big Brother says he keeps skipping my questions. Uh-oh, now I got to go back and find it. If you could just type it again, I'll find it here at the end. I apologize for that. I'm not good at multitasking. So, been to Notch Peak on the way to Great Basin National Park. Yep, I got some plans to go down there in the fall too. Yeah, if you're not sure or familiar with where he's talking about, that would be in western Utah. Oh boy, where's it at? Baker. It's, some of you are like, it's right there. It's further south, isn't it? You need to have the roads figured out. Anyway, so there's a really spectacular mountain range. Here we go. With a very large sheer cliff. So western Utah is kind of like the land that time forgot. I don't know, with incredible geology. Every mountain range is completely different. So there's Notch Peak. This is one of the tallest freestanding cliff faces outside of Yosemite. These gray layers are limestone, Paleozoic limestones. And then the coolest, that's cool, right? So you got seafloor that's been uplifted, very cool. But what's even more cool is the rocks down here, these brownish rocks are Jurassic age granites. So you literally have these granites, this magma has intruded into these limestones, and there's some really cool contacts and features in there. And so that's on my list for this fall because it's not too far away. And it's also got lots of other cool things nearby. There's some trilobite beds. There's also some climbing down there, so that's enticing to me. But yeah, there's a lot of cool things happening in western part of Utah. Okay, let's see. Notch Peak. What makes the Teton Range unique? From Diane. The Tetons are pretty notable, and they're a national park because they look really pretty. No, just kidding. It's the mountain range is just another one of these basin and range uplifts. So there's a big fault that runs along the, let me orient this a little bit better, along the east side of the mountain here. So we've got a big fault system, the Teton Fault that runs here. That over time, over the last 6 million years, has pushed the mountains up, dropped the valley down. So that's created a very dramatic and spectacular escarpment. What you see is the Teton mountain range in front of you. And that uplift coincided, at least in part, with periods of glaciation. So you had glaciers forming in these high peaks, forming these big, beautiful U-shaped valleys, creating these jagged, spectacular peaks like the Grand Teton. The Tetons have a lot of cool stuff. These rocks are mostly really old, 2.5 billion year old basement rocks, metamorphic and igneous rocks. But there's some other stuff going on there as well. I just did in June a presentation in Jackson and met Mike, a new friend that I stayed at his house. And he gave me a bunch of cool ideas of places around the Tetons where I could do some videos. So I'm hoping to get back there in the fall as well, maybe in August, and do some videos there. So very cool. Let's see, will North America break up at that fault line? Oh boy, see, this is a problem when you're just scrolling through and catching little things. Curious about any active volcanic systems from Idaho through those states directly south of Idaho? Other areas that are volcanically active or potentially active, there is some stuff in well, anywhere in the basin and range where you get this extension, you're thinning the crust and you're making it easier for magma to be generated and magma to make its way to the surface. So there are young volcanic fields down here around St. George, which I kind of talked about. Other areas around here and like right along the where the Wasatch come down here around like Fillmore. There's ones out here in the middle of Nevada. There's like Lunar Crater, and then there's lots of ones here along the east side of the Sierras. So those areas, if I'm reading the question right, would be places where there could be potentially active systems as well. Yeah. Let's see. Great Basin National Park. Can you please examine Pinnacles? I have been to Pinnacles National Park. I don't know if my travel plans will get me there, and that's this area right about here, more or less in California. Don't know if I'm going to get there this next year, but what's great about these videos I'm doing, unlike maybe other YouTube folks, is like I'm never going to run out of content because there's just so many places to go. Like I'm in Idaho and I kind of branch out to close areas, and there's still just so many places I can get to. Pinnacles has really cool geology, just like a lot of places. I will be down though this winter in the Mojave and the Salton Sea and Joshua Tree, and that's an area I know pretty well, having lived in Blythe. So my plan for November-ish is to get down in this region for maybe 4 or 5 days and do some videos down there. So okay, cool. Leslie Gulch. Leslie, how appropriate. Leslie asks, are you going to Leslie Gulch? So Leslie Gulch is right here along near the Idaho-Oregon border. Leslie, the person that asked this question, will probably not be happy to know that I literally was like right here on, what day was I there this week? On Wednesday, because I had more consulting work to do. But unfortunately, we were there like all day and I was with someone else and I didn't want to drag them over to Leslie Gulch, which is kind of over here, to go look at rocks and watch me hold up a camera and make a video. So it's on my list. I will try to do it, but we'll just have to see. Let's see. Were the Tetons formed in the southern hemisphere, like the Tetons today, like these Tetons? No, these were uplifted 6 million years ago, so they were pretty much where they are today. But if you're alluding to the fact that North America has spent some of its geologic history south of the equator, yes, where the Tetons or any mountain range in Wyoming uplifted at that time. Maybe the older rocks, maybe if that's what you're referring to, the Archean rocks, I'd have to look, but there's a possibility that in the Archean, if we're south of the equator, you had some mountain building events there, but those would not be the modern Tetons. So yeah, Blythe, California, an inflamed boil in the buttocks of the world. Yeah, it was rough. It was interesting to be there. So let me, I think I've caught up. Let me go to this one outcrop that someone sent me a picture to right before we got on here and asked me about. So apparently they saw this on another YouTube channel. It's called the Charlie Brown outcrop. Let me give you some context here. So it's down in the Mojave. It's in California. Here's the California-Nevada border. Here's Pahrump, Nevada. Here's Shoshone, California. And this outcrop, I'll take you down to road level here so you can actually see this thing. But it's this big black stripe running through this here. And what's great is I was actually able to figure it out without looking anything up. So that's always nice when you get the validation of like, I think this is what's going on. But this is a lot of ash, and this is the base of another ash layer here sitting above it. And this black is a rock called vitrophyre. And vitrophyre is when you have silica-rich ash or rhyolitic ash that cools very quickly, but not quickly enough that it makes like obsidian. So obsidian is usually from lava flowing, like silica-rich lava that flows, and it cools so quickly, usually because of its composition and water content, that no crystals form. So obsidian is actually a rock that doesn't even have mineral crystals. It's just unordered elements, if you will, atoms. But this actually does have some small crystals, but a lot of it is quite glassy like obsidian, and that's what vitrophyre is here. So this is just a road cut in ash. And then I did notice on the little Google, when I looked at this, there's a nice little fault here as well. So you can see this actual offset. So that orange layer there, I'm guessing might be, maybe not, might be the same as that one up there. But either way, you can see there's definitely a fault here because these layers don't continue across. So a little bit of offset there. So hopefully that answered that viewer's question on that. Let's see, anything else? Yeah, Wonder Hussy, that was the name of the YouTube lady that had stopped on the road, and she was trying to do some geology. She apparently looked up some stuff because she knew the word vitrophyre, and she did a pretty good job explaining it. I'll give her some credit for that. Will Death Valley keep dropping? How low can it go? From Max Picks, Utah. Let me get rid of that. Yeah, I mean, if basin and range extension continues across this region, and Death Valley's over here, then we continue to thin the crust. And this is, we know this is going on in Eastern Africa. It's not that different from what goes on at these other divergent boundaries in the middle of like the Atlantic Ocean. So if we continue to extend the Earth's crust and thin it, these basins, which are low already, like Death Valley below sea level, would continue to get lower. And what you might predict at some point, and this has happened a bit in the past, so the Gulf of California, so a continuation of this divergent boundaries down here, right? So we've got, I don't want to make this too big of a spiel, but the San Andreas Fault is here. And really it starts right about there. And the San Andreas Fault moves this plate relative to this plate. But let me zoom in a little bit further. I have to like kill the annotations to zoom in. So, okay, I'll try to keep this short because I could go, I'm dangerously close to going off on a deep tangent here, and I don't want to. So here's the San Andreas Fault, and it ends right about there. Then there's other small sets of faults parallel to the San Andreas that come down through here. And maybe I'll leave this on. I don't want the pin to vanish. I want it to stay on. Let's do this. So here's the San Andreas Fault, like something like that. Here are other small faults, and these probably aren't perfectly drawn, but you get the idea. They come down through here. Well, what's happening is, and these faults all have this sort of motion to them, right? So this fault's moving this way, this fault's moving that way. Well, in between these, basically you have these little extension points. So these are little, like, I know this one's a little messy, but these are little baby divergent boundaries where the plates are spreading. And this is fundamentally why, let me get rid of that real quick. This is fundamentally why, how do I clear that? There we go. This area is low. So not only is Death Valley low, but if you come down here to the Salton Sea, it's 230 feet below sea level. You come up here to Palm Springs, this area in here, and this area around Palm Springs, and they're below sea level as well. And so my point is that what you'd expect is if this basin and range process continues indefinitely into the future, one possibility, this isn't a prediction, it's just a possible model, is that the ocean would start to encroach some of this area as this crust drops and subsides due to the extension. And so the Gulf of California could get longer and extend further into the US and into California, and inundate this area. Now that's probably like a long ways down the road, but you could drop these basins like Death Valley so low that the only reason that the sea's not in Death Valley is there's enough high topography between Death Valley and the ocean. But if the ocean's closer, then you flood that with the ocean. So anyway, hopefully that helped as a question or an answer. Diane, do you accept rock samples for your collection? Oh boy. So I don't have my own personal collection. I do have rocks here at the college. I firmly believe in no rock left behind. So whenever someone's like, hey, I've got some rocks, do you want them? I usually say yes, but I don't always. I do have finite space here at the department. And so those rocks don't always make it into the collection, but I do have some places outside the building here where I have rocks and the students sometimes use them. So Diane, I'm going to say yes, but what I don't want is for you to like dump, 3 pallets of rocks on my front porch. So if you want to let me know what you're specifically wanting to donate, yeah, I'd love to, all rocks can be good for teaching. But at some point you realize like, okay, I don't need 400 quartz crystals to teach students what a quartz crystal looks like. I just need a couple. So anyway, hopefully that makes sense. So willing to accept rock samples, would probably want to know what those samples look like or what you're interested in donating. So yeah, and David brings up a good point. As we rift, that opens up the valley, but the sediment fills it in. And so there is a balancing act there. But ultimately, if the crust gets thin enough and or extension is rapid enough, this is exactly what's happening over to some degree, in Eastern Africa. Right in here, this little country called Djibouti. Take off the roads. This is the beginning of the East African Rift coming into Africa here, and there are places around here, and this is just what I've read, so if I'm wrong, I apologize, but there are places in here where the rifting is even historically, land has dropped and lowered, and villages have had to move or something because of the crust being thinned and dropping down. So one possibility here in East Africa is this rift splits through Ethiopia, connects to these lakes here, these long skinny lakes. There's actually a branch of the rift that goes this way, and then there's another one that comes around this way. And then in the future, this chunk of Africa might be further to the east and not connected to mainland Africa, kind of like Madagascar. Madagascar was a chunk of Africa that was rifted off in the past. So anyway, good stuff. I'm mainly looking for the CAPS ones. Those are kind of the ones, because I just can't read all these in real time. So if you're just asking a question to the group in lowercase, that's fine. But if you want to ask me a question, try to make sure it's in uppercase. Oh, I think I cut up. Oh, and Max, thanks for the donation, much appreciated. That will help when my wife's like, where have you been for the last 2 hours? Oh, look, I made a couple bucks. So Dead Sea is also a rift. Yep, absolutely. So the Dead Sea and the Gulf of Suez and the Gulf of Aqaba, or the Red Sea. Yeah, the Red Sea, sorry, the Gulf of Aqaba here. Gulf of Suez, and then the Gulf of Aqaba rift system goes up into the Dead Sea. This is actually, it's not just this is actually 2 things geologically. It is a plate boundary runs through here. Partially it's a strike slip boundary, but it's also partly extensional. So it's what we call a trans-tensional boundary. So it's doing 2 things. It's stretching more or less east to west, but it's also moving things north to south a little bit as well. So many cool places, so much to see. And I know a lot about rift systems because my master's research was on understanding how the Gulf of California opened up. And I was looking at a lot of structures in these highlands here, west of this town of Loretto, looking at some of the faults and the folds that formed when the Gulf of California opened up about 10 10 to 6 million years ago. So could you briefly explain why there's a general lack of volcanoes in Africa? Sure. So Africa, I got to zoom way out. So in general, we see volcanoes where we see plate boundaries, right? And so if you look at Africa, you got the plate boundary out here in the Atlantic, which comes down here. It goes off to the Indian Ocean. Then it comes through the Red Sea. Terrible drawing. And then through the Mediterranean, more or less like that, right? So you would expect volcanoes to be close to this plate boundary. So we get volcanoes out here, they're just underwater. So they don't affect people, but there's plenty of volcanoes erupting underwater. In fact, these divergent plate boundaries have more of the Earth's volcanoes than any place on Earth, right? And then we get volcanoes here in the Red Sea. Now we talked about the East African Rift. So there's volcanoes coming through here and here. So like Mount Kilimanjaro. So this is the volcanic region of Africa. But there are no volcanoes along the margin, the continent of Africa, because it's just too far away from the plate boundary. So we don't have a subduction zone here where one plate's diving beneath another. We don't, for the most part, have, I think there are actually a couple little hotspots in Africa. And again, I'm no expert on African geology, so just temper this all as best you can. But the big, I guess the 30-second answer would be most of Africa as a continent does not lie along plate boundaries or processes that generates volcanoes. It's a stable, what we call, this is a stable continental margin, what we would call a passive margin, meaning there's not much dynamic activity happening here. The passive margin of Africa is right here. This edge of Africa is very geologically active with earthquakes, with volcanoes, with different processes like that. So hopefully that helps a little bit. That was for Michael. Jeff, do you have any thoughts on Boise Basin gold veins? Huh. Funny you asked that, because I was just, let me get rid of that line. We just had a little rafting, camping family trip north of Boise along the Payette River. The Boise Basin, if you're not familiar with what he's talking about, is, zoom back out so you can see where Boise is. There we go, we'll put Boise down there. The Boise Basin more or less sits, let me use yellow, that'll be good. More or less here. And this was a historic gold producing location. So there was a lot of gold that was discovered and then produced in the 1870s, 1880s, 1890s, probably going into the 1900s a little bit, but that was the main heyday of this. So you've got towns like Placerville and Idaho City that were originally gold producing areas. And let me go back to the question. Now I forgot exactly what the question was. Oh, why, let's see. Yes, the gold veins. So a lot of these are placer mines, which are mines where they're mining the gravel out of the stream deposits. That's what a placer mine is. When you get down into those rocks and river rocks and gravels transported by a stream, think about like someone gold panning using a sluice box. That's all placer mining. There are some hard rock mines that were there as well, but I think most of the mining that went on there, if I'm correct, was placer mining. Why is there even gold there? Well, in the Eocene, about 45 to 50 million years ago, or as Nick likes to call it, the crazy Eocene, that's supposed to be a 5, oh boy. There was a period called the Chalice Volcanics. So there was extension going on in this part of Idaho, and that extension was mainly northwest, southeast. And so that extension actually produced a bunch of dikes, basically fractures in the rock and intrusions that trend this way. And there's a whole swarm of them in this area. This is called the Boise Basin Dike Swarm. And actually I did a video on one, I haven't posted it yet. I don't think it's a great video, and I wasn't able to like look at the rock super close because I had the wrong shoes on, and was kind of a quick and dirty thing. The sun was setting, but I'll post it anyway. Take it for what it's worth. But these dikes here and the intrusion of magma into these dikes mobilized gold with the magma and the fluids, and then concentrated it in some of these rocks. Then they got weathered into the stream systems and then mined out later. So so Jeff, hopefully that helps a little bit. So I mean, any one of these topics you guys are asking could easily be a 30-minute lecture. So hopefully these short answers are at least somewhat helpful and adequate for right now. So yeah, La Palma is a hotspot. Yeah, big line of volcanoes in Cameroon. Yeah, sometimes, I mean, Google Earth's just a fun thing, and sometimes, just like a lot of rabbit holes that are out there, I've just gotten into looking at places, and then you just kind of get in here and you look and like, oh my gosh, look at that, and what's going on here. And yeah, in Cameroon, oh boy. So I don't know if there probably are volcanoes in there. Those are harder to see with all the vegetation. I remember finding some, I mean, who knows what that is, but that could be a volcano. Those could be lava flows, right? I remember just sweeping through the Sahara and finding all sorts of cool things. Maybe it was in Libya. Oh yeah, I think it was in Libya. There's a volcano. There you go. So boom. I don't know anything about this volcano other than it's probably only a few thousand or so years young. So yeah, you can spend a lot of time just kind of looking at like, why are these? Oh, and there's like these could be dikes or fissures here, right? So I'm doing this on the fly with you, right? We're discovering this together. Like, what the heck are these things? Yeah, cool stuff. All sorts of fun things out there. Yeah, Michael, there is not a subduction zone on the west coast of Africa. How did the mountains along the coast form? So there's not volcanoes there now, but your big mountains here, and like this looks like a cool place for awesome geology because, yeah, get rid of these. You can see the trend of the rocks here. See how the rocks go east-west? You can see, so this is what we call strike. The rocks are trending or striking more or less in an east-west direction. And if we actually got in close to these and looked at them in an oblique view, so I know nothing about South African geology. I am making this up as I go. So, but geology, I mean, I don't have to know South African geology to recognize patterns and landforms that are similar from one place to another. So what's happened here, the rocks are folded. So these rocks have been compressed. Here, let me turn it back to north being this way. These rocks have been compressed in this direction at some time in the past. I don't know when that took place, but the mountains you have here and the topography you have in South Africa is most likely due to a convergent plate boundary, a collision plate boundary between Africa and some other piece of continental crust at some point. I don't know when that took place. You can probably jump on the internet and figure that out in a few seconds. But this, even though this is not a plate boundary today, this was a plate boundary at some time in the past. And we could say the same for moving a little closer to home, like the Appalachian Mountains, right? You get in here. So now let's turn the borders on so our US friends and non-US friends can see. So now let's look at West Virginia, Pennsylvania, Maryland, this area. Look at all the patterns. Look how the rocks are oriented in this southwest to northeast direction. And then they look at these beautiful lines here. And I mean, some of them are like intricately folded. Again, I don't know. I've never even been to these locations. I don't know much about Appalachian East Coast geology, but these all formed because there was a collision in this direction between two tectonic plates. And in this case, it was North America and Africa about 250 million years ago that caused these rocks to be pushed together, crumpled, folded, deformed, maybe metamorphosed. And you can see that pattern there. And if you just get on Google Earth and go crazy, you can find these sort of things like in all sorts of places. Couple more real quick. So if you're into this sort of thing, here's another cool place to look at it. So if we go down to Mexico, and just go over the border from Texas. Take that off there. Look at these crazy patterns. I mean, so it's the same sort of thing. This is collisional tectonics. This is convergence. This is rocks being squished due to shortening, thrust faults, folding. You can head across into Africa and see the same thing in Morocco, right? So if we come up in here into these parts of Morocco, you can see some of these folds in here. You can see these in Australia in some places. Yeah, same sort of thing. So yeah, hopefully I answered that. Sorry. Google Earth rabbit hole. Yeah, Chad, that's where it was. Chad and Libya. I think it was Chad where I saw some of those volcanoes before. Awesome. Okay, I'm not seeing any more questions. So hopefully that helped a little bit. We've been on hour and a half-ish. I'm happy to spend a couple more minutes with you, but maybe that's good for now. I'm happy to do more of these. I guess maybe since you guys asked some questions, maybe I can ask a couple of questions as viewers. Let me know what's working and not working. I sort of feel like the YouTube thing for me is a lot of trial and error. And so I'm just trying to figure my way around this whole thing too. And trying to improve on things. I've obviously, if you've watched me long enough, you've figured out that you've probably noticed that, like, hey, he's figured out a few things. He's adding titles to the thumbnails, and he's doing some basic video editing, things like that. And so, in addition to just content, I'd be interested, if you go back far enough, you can see like, oh, like these are just little screen grabs that YouTube makes. If you've been with me since like the very beginning, like the Death Valley videos, they've definitely come a long way, because those videos I don't think are good at all. And I've started to replace a few of them. So let me know what you're interested in. It could be topics. I have some ideas of some things I'd like to do. I think for in the short term, what you can expect is more of the same. The field-based geology videos, I think, will always be my bread and butter. Where those videos take place will largely be predicated on my personal travel or just places I want to go visit and do some videos. I know a lot of you are located in some other places and you'd love for me to come and do videos there or help you with the geology there. But realize, that somewhat constrained geographically and economically to this part of the Western US. Yes, I've been to Iceland and I will try to travel as much as I can. But unless someone like, flies me out to like, some place, that'll be kind of the focus for now. But I really think that should still be valuable, because I think a lot of you are figuring out, hey, even though he's in Idaho and he's showing us this stuff in that area, I've seen something similar where I live in this other place or in this other continent. And so, the connections are there. Like the rocks at Antelope Island, there's rocks that look like that in other places too, right? So you can really transfer that knowledge to other locations. It doesn't always have to be super site specific. So expect those. I would like to continue. What I want to do as well is explore more of these. I'd like to do more, because I didn't think they would do well initially, these like little kind of lecture-y videos. So the most recent one was this Bonneville flood presentation I made over in Jackson. What really astonished me was, like, of all the videos I've done, the one that like did the best in terms of views, not that that's the end all be all goal, was this silly little 27 minutes sitting at my computer with bad graphics and poorly executed lecture on the Bonneville flood. That one has almost 300,000 views, and I don't know if it's because it's a flood and mega flood and like it's got the right buzzwords in it that it's attractive. But then I did one on Mount St. Helens that I thought was like, yeah, Mount St. Helens has a cool story, and that one didn't do as well. And again, that's not what I'm pointing to. It's just, as someone making the videos, what I sometimes think is going to do really well in terms of people watching it and what really happens, there's a big disconnect there. So clearly I don't understand, not just you individually as viewers, but just collectively. Like, I really thought these footprints in the Hawaiian ash, I thought that was going to be amazing, because like that's something I've never seen before. Like a person's footprint in an ash bed from over 200 plus years ago, almost 300 years ago, I guess, 250 years ago. That's like really cool. That one, did okay. And I don't know. I'm rambling now, but the point is that any feedback you can give me, whether it's live streams or locations or formats or camera things. I know I pan too quickly and I'm trying to slow down. Just what am I using for these things? Right now, I'm using a GoPro Hero 8 on a selfie stick with a little foam wind buff thing. And that seems to work pretty well. I'm not a super techno gadgety guy. So would I like to make better videos? Yes. Do I want to spend hours editing and making them look slick? No. Am I a YouTuber? I guess. Am I a really good professional YouTuber? No. Like, I have a real job. This is just sort of something I do on the side. It's something I really enjoy. And it's fun to like connect with all you folks. But so hopefully they'll get a little bit better. So I guess what I'm saying is, if there's easy things for me to do to make things a little better for you, if there's anything I can do to make the product better for you as a viewer, I will try to do that. But you're going to get more hand-drawn, diagrams from the field. Sometimes there'll be nicer ones. It just sort of depends. So anyway, let me quickly scroll through, because I just went on a rant there, and see what some other people said. Maybe I opened up a big Pandora's box or whatever. Okay, so let's see. Yeah, someone says to get a drone. I do have access to a drone here at the college. I do know how to fly a drone. I don't know how to fly a drone really well. I do know how to put the drone footage into the editing thing. Yeah. Will I get a drone of my own? Maybe. The little DJI Mini, Mavic Mini is like not that expensive if I get it used. Yeah, maybe. Might do that. I've added some things though. I got the little like location thing. So hopefully some things have been added that are helpful. Let's see. Yeah, if you get a permit to the wave, that'd be great. I hiked the Buckskin Gulch once years ago. That was great. Yeah, Idaho's really cool. So yeah, I'm not getting anything from the state, but I'm definitely promoting the state's great geology and such. So that's fun. I'm kind of reading these quickly, just scrolling through. Yeah, there's lots of good things. Nick is awesome. Myron Cook, he and I have talked. We went to the same school, but we didn't overlap in time. He's doing good things. We're all just different, right? Like, I'm putting out, I don't know, I don't even have a schedule. It's just kind of like when I go somewhere and I get some videos, I'll upload them, but I'm trying not to over saturate the content. Like, I don't want to put up one a day. So I'm kind of doing like 2 to 3 a week on average. But there might be a couple weeks that go by with fewer. I do have a couple more. So I'm a little backlogged right now. I've got like 2 or 3 more ready to go in the hopper. I think the next one will come out on, I'll probably put out Sunday if I wanted, or Monday on the Henry Sport Caldera. Yeah, so let's see what else we got here. They enjoyed the Q&A. I'll read all these later, all these comments. So if I'm just scrolling and missing yours, I apologize. Bonneville flood, good. I'm glad people like that. I think the one I did on the Bonneville flood, the most recent one, is that's the one to look at. That's like, I think that's the most comprehensive one, but I definitely could do more field videos on locations in the Bonneville flood. And for me, it's something I'm hugely interested in, and it's nearby. So possible lecture topic, formation of Great Sand Dunes National Park. Gosh, I got to get down to Colorado. Every time I go to Colorado, I think I need to spend more time in Colorado. Yeah, tactics you can apply to get the most from the dreaded algorithm. And, you know, I want people to watch these because I love geology and I want to share it with people. My videos are monetized and I get a little bit of money from them, but I'm not doing this for the money. I'm like, you know, am I getting some money from doing this? Yeah. And that helps like justify some of the expenses of getting around these places. But this is not changing my way of life. I'm not quitting my day job. And that's not why. So would I like to reach a bigger audience? Absolutely. But mainly because I want people to just know these things and be excited about them. So anyway, but the YouTube algorithm is something I'll probably never figure out. Okay, last little bit, and then we can sign off here a little bit. San Rafael Swell. Yeah, we were down in Hanksville the last 2 springs, and I've done a couple from there, but not actually in the swell. I did some on the Henry Mountains, some slot canyons. Yeah, boy, they're coming fast and furious. I've got a time to make a YouTube video from a field. Oh, the time is huge. Yeah, that's really, you know, geology, dude. It's really not that long, especially if I already kind of know the story. Then it's just like, oh, here's a good spot, here's a good outcrop, and I can like pull out the selfie stick. I can usually do it in like 1 take, maybe 2, with very little scripting. As I get into places I'm less familiar with, then it's a little more legwork and research and that sort of thing. But for the most part, it's you know, once I'm there and if I kind of have the story a little bit, or I've seen the outcrop before, yeah, you can't do drones in national parks. I've learned the hard way without telling you the details. That doing these videos in national parks, you want to be very careful about not only, I mean, drones are easy, about where you go and what you do. And I'll just kind of leave it at that. Yeah, the Iceland stuff was at the beginning, Dave, so you have to watch the recording. More hand-drawn diagrams made hanging from a cliff. Huh. Yeah, and I mean, that's another thing where I'm a little bit different, right? Like Nick does good things and Myron does good things, but you're going to always get, as far as I know, some people like it. Like I love rock climbing, and sometimes when you're on like a 800-foot climb, like I'm going to go next week, I'm going to be in the Sawtooth, and my wife and I are going to do this big climb in the Sawtooth. And as I climb, you'll be able to see these beautiful glacial striations and polish on the rock, in addition to seeing all the cool details in the granite. So I thought that would be a cool video, is to just video, you know, as we make our way up the cliff, just a few little sections in there. And so rafting and climbing and hiking and some of those things I like to do, those will always, if I think it has a connection to the geology, or I think it's just something some people will like, I'll always include that sort of thing. Yeah, structure and drone footage is great. Ask your students to edit. Yeah, I could. The problem with our little community college is the students are going quickly. They're only here 2 years and then they're gone. So you're always dealing with like turnover and stuff. So yeah, Myron is Mr. Rogers. I thought it was the Bob Ross. He's just so, he's got such a mellow personality. It's kind of fun though. I mean, I at first I was like a little intimidated by Nick and Myron and not sure where I kind of fit into the landscape. But really it's just like we're all doing good things, but we're doing it in our own way with our own personalities. And I think it's great that you as the viewers can learn from each of us, and that your learning style works for all of that, right? Because we're all our own sort of our own flavor. Good stuff. So are your classes that you teach at the university offered online? The only online, I do teach online classes. I never think my online classes are as good as my in-person classes. But obviously you could take them, but they're tuition classes, so you pay tuition just like any student. I've thought, I don't know. I'm open to the possibility. I don't know how this would actually work. I know Nick's done some of his 101 lectures, but were they actually like video lectures or were they just audio? I'm not sure, but I'd be open to doing those or putting those out there as well. Yeah, Myron and I have talked about getting together at some point, but I don't know, but we don't have any like firm plans, just like we're open to it. Yeah, and I'd like to do more. I know Nick does a lot with other geologists, but you have to remember where he's at in the Pacific Northwest. He's at a bigger university. He has access to a lot more geologists than I do. I'm in a much more remote location, a smaller school. I am the geology department. Do I know geologists and do I have colleagues? Of course I do, but they're not here. And so it's a little harder for me to do that, but I'm open to like, meeting someone in the field and doing something together for sure. Let's see. Any topic on the effect of water, of lava? Oh yeah, water lava interaction is definitely something I'm interested in. Just scrolling through the last of these here. I think the outdoor adventuring. Okay, cool. So people, yeah, like all good stuff happening here. Everything I'm reading here for the most part is positive. I love that we have this community of people that that all kind of seems to get along and kind of likes the same thing and is respectful and just civil. That's always nice. Oh yeah, the Rock Lab videos. So what's interesting is I'm interested in doing those. I think the ones I did are fine, but I kind of did those not knowing what I was doing. And so I'm speaking specifically about I can go there real quick. The rock identification with Willsey and the mineral one. I'd maybe like to circle back and I don't know if I want to redo them. And I don't know if I want to do more per se, but I've just really they just really resonated with more people than I thought. And so that's just been awesome. I wonder if I could organize them better. I don't know. I'm just kind of open to like maybe going back there because really that's important, right? If you want to understand geology, you've got to speak the language of rocks, right? Before we get into interpretation and what happened here and volcanoes and whatever, you have to know what you're looking at to some degree. And that starts with minerals, and then that goes into rocks. And I kept it kind of that 101 level, which I think is pretty helpful. So yeah, fascinated by the sawtooth, which, yeah, I wish each state, well, yeah. Yeah, rewatching those. Okay. All right, I think I've caught up to everyone and I need to get a drink of water at some point. So I think I covered everything. If I didn't get your question, I apologize. Maybe hit me up privately with an email or something, a message, and let me know. But you guys are awesome. I appreciate folks who hung in here, all 100+ of you, for this kind of rambling Iceland Q&A thing. Let me know what you think. Should we do these? Like I could do, one of these a month, maybe once every 3 months. I don't want to like oversaturate the situation, but happy to do them. I think it just sounds like I'll just keep doing what I'm doing and you guys hopefully will enjoy it and continue to watch and support. And I really appreciate that. And we'll just keep building our geologic knowledge together. I do have a fun one. I haven't done the video yet, but there's a place that Jack showed me, Jack Belk out of Oakley, near where he lives, that I haven't figured out. Like the outcrop has like lots of things going on. I haven't totally figured out what the story is there. So I thought it might be neat to like do a video where we just like work through it together. Like, okay, what kind of rocks are here? What are here? And what are the possibilities in terms of how this all came to be in the processes? So I might do something like that. Anyway, I'll just keep innovating, doing my thing. We'll figure it out. Yeah, maybe we can do another Q&A. Definitely if there's a current event like the eruption in Iceland that I feel like I can lend some expertise to, I feel qualified in doing, I'll do that. Oh, someone did, last thing real quick, I did the video on the little consulting job that I did, or I'm doing, it's kind of still ongoing, on the zeolite mine out near the Idaho-Oregon border. and someone had messaged me and asked me to do another one like that. So the one I'm talking about would be like this video here, I guess. But the problem with that is I need to make sure, first of all, I don't do consulting jobs regularly. They kind of come and go. And then I definitely always have to make sure I get permission from the client, the person I'm doing the work for, to post that. So that I'll definitely ask if another consulting job falls into my lap and the person or company is willing to do that, I will. But sometimes I'm working for like gold or other metal mining companies and they're very hush hush. Sometimes I have to sign like a non-disclosure agreement. So we'll just have to see. But I think it would be cool for you guys to see kind of what happens and what actually takes place in terms of what geologists do in those sorts of environments. So anyway, yeah, that's it. Thanks so much for joining me. I'm going to go ahead and sign off. Have a wonderful weekend. Expect a couple more videos coming down the pipe in the next few days and weeks to come. I've got a very aggressive schedule. I'll maybe post a better plan of what you can expect coming down the way pretty soon. But thanks again for joining me on the live stream. Shawn Willsey, geology professor, YouTube channel. Appreciate all your support in every which way. And have a great day. Thanks so much. And yeah, adios.